So we're going to go over the important steps of how to solve a right triangle. In other words, find all the missing pieces. For example, let's say we start with this. We're given a hypotenuse and one angle. We should be able to find, obviously we know the 90-degree angle. We should be able to find this angle, this side, and this side using calculator, trig functions, and an understanding of how things set up here and what sine, cosine, tangent, for example, are. So here's how the process works. Now this folks, is probably the first time we've run across this. I'm going through a process. You might want to take some notes down on how the process goes and what the steps are in this process. And you might want to trust me that the process is going to help make complicated problems easier. What I don't enjoy seeing is students who obviously did not pay attention to anything about the process and come up with questions to me about, like, how do I do this? And I said, well, go through the steps. And I can't even tell what steps they're making mistakes on because they don't even know the process. And they say things like, oh, I like to do it my way. Well, if your way doesn't work, you do it my way. So here's my way. So here's my triangle. First of all, draw a picture. Make sure you draw a picture. That helps identifying the major players. Now, I have this angle, and I think I'm going to want to use that angle. It's not hard, by the way. I think the first thing we could do is to find this angle, because we know the angles of a triangle always add up to 180, which means since this one's 90, this angle and this one have to add up to 90 degrees. So I could go and grab a calculator and say, all right, 90 minus 32, get 58. So this is a 58-degree angle. But it's important that I choose an angle to kind of use as my reference. And I would use this, the one that's given. Whenever you can, use the information that's given, not things that you calculate. What if I screwed this up and made it a 68? And then if I did the whole problem based on that, all of my stuff would be wrong. So try your best to use the stuff that you're given because you're a little more sure about that. All right, so for this angle, what are my sides? Well, what's the hypotenuse? Well, I always start with the hypotenuse, and that's going to be right here. And I label it on the drawing. I go the opposite next because that to me is the easier one to figure out. So the opposite's going to be this over here. Remember, this is all for this angle. If I happen to be using this angle, it would be different, but we're good. The adjacent is over here. I always identify that last. All right. So then I pick something to go after. In this case, I'm going to go after this one first. So I am going after the opposite. Obviously, I can't use the adjacent because I don't have it. And you don't want two things that you don't know. So we're going to use the hypotenuse. So wait a second. I have opposite and I have hypotenuse. And then little bells go off in your head because you have SOHCAHTOA down to the point where you don't really need the SOHCAHTOA thing. You just know it. You hear opposite and hypotenuse and you're like, tangent. No. Right. Exactly. No. You think sine. All right. So I think opposite and hypotenuse, I think sine. So the sine, and then I write that expression down. I don't try to do anything in my head. Sine of 32, the angle in question, should equal the opposite side, the thing I don't know, I'll just put opposite, over the hypotenuse, which I do know, 19.5. And I'm solving this. Now in this case, solving it just involves multiplying both sides by 19.5. So let's look at how this works out on a calculator. I'm going to take 19.5. Let me get my calculator up here a little higher. There we go. Where's my clear? I'm going to take 19.5 times, now in this case, with this type of calculator, I have to type in the angle first. 32, and then I hit sine. That's the sine of 32. I have not yet finished the multiplication that I talked about a moment ago. I have to hit equals. There we go. So the opposite turns out to be 10.3. If your calculator is not giving you that, one of the things you want to check is to see if your calculator is in radians or degrees. Let's see what that looks like on this one. So for this one, let's see. There we go. I am in, you might notice right here, degrees. All right. I don't know if I click on that, what happens? See, it changes to something called radians. You don't want that. So if you're not getting the right answer, it might be because your calculator is in radians, not degrees. To change it on the TI-80 whatever's, the big ones, go to mode, I believe it is. And in there, there's a way to toggle back and forth between radians and degrees. I don't want gradients. That's a whole different thing. And I want degrees. So make sure your calculator's in degrees. You should get this. 10.3. Now, you could, I'm pretty confident with that answer, so you could use Pythagorean theorem, because you know the hypotenuse on one of the legs, and you could find the adjacent that way. I'm thinking that's a bit of a long way around, and I'm also thinking that's going to be a problem, because what if I did make a mistake here? Remember, try to use the numbers you're given as much as possible and not any number that you calculate. Don't trust yourself. It's a good lesson in life. So, if we're looking for the adjacent side and we want to use the hypotenuse, what trig function do you want to use? That's right, cosine. Cosine of 32 degrees. What is a cosine of 32 degrees? It's going to be the adjacent, which I don't know, over the hypotenuse, which is 19.5. Same idea. I'm going to multiply both sides by 19.5. So that the adjacent is equal to the cosine of 32, whatever that is. I'll write it this way, times 19.5. Use parentheses to show the multiplication. So 32 cosine times 19.5 is 16.5. 16.5 is what I think I said. This is a good time to check and see, does that make sense? Well, the longest side should be the hypotenuse. Yes, good. It is still the longest side. The 58-degree angle should have the bigger side as its opposite. So this side should be longer than this one. And it is, by a little bit. Not a ton, but a little bit. So, okay, so this all makes sense to me so far. All right. So that's one example problem. What if let's try another one. In fact, we'll even use the same numbers, or if we could. We don't have to. Let's see. Yeah, I'll use the same numbers for now, because it really doesn't matter. So let's say I have my 32. And instead of giving me the hypotenuse, they give me the opposite, the 10.3 centimeters. Well, now I'm looking for the hypotenuse. Remember, first thing I want you to do is kind of go through and label what they are. This is the opposite, and this is the adjacent. So if I was faced with this problem, how would it be different? In some ways, it would not be different at all. We would still find this angle, but we're going to use this one. And I'm actually going to start off with the same trig function, because I have the opposite, but I'm going to want to try to find the hypotenuse. Well, when I say the words opposite and hypotenuse, sine comes to mind. So I write the sine of 32 equals, so it starts off the same, just be careful. Now, what is the opposite? Well, it's 10.3 over the hypotenuse. Okay, now, this one's a little weirder. What do I do when I have the unknown sitting down there? Let me give you a hint. It turns out that it is perfectly legal to just switch the position of this and this. I will now explain why, but after that, well, let me write out what it would look like. So it is perfectly legal to do this in algebra. To switch whatever's here with whatever's down in here. Boom. They can be interchanged. Here's why. what you really do is you multiply both sides by the hypotenuse. That cancels it over here. Notice there's no hypotenuse there. At the same time, we divide by the sine of 32, which down here just puts it on the bottom. Now, that cancels this over here, which makes sense because once again, you'll notice there's no sine of 32 over there. But it does leave it over here on the right. So I end up with 10.3 divided by the sine of 32. Now you can go through that every time, or you can remember. If you have, I'll just make up some letters, m equals q over l. You are more than welcome to switch these two and say L is equal to Q over M. That's fine. Perfectly legal. So we do that here. And we do this problem. So we got 10.3 divided by the sine of 32. Now we already know what the answer is going to be, right? 10.3, but it's good practice anyway. Divided by 32 sine equals 19.4. Oops. Yeah, we're good. Rounding error being what it is, we're good. I'll try it now for the adjacent side. Well, that's the adjacent, and I have the opposite. All right, so I don't want to use this if I can avoid it, because what if I made a mistake? But I'm looking for the adjacent. I have the opposite. Which trig function is that? You're right. It's the tangent. First time we use the tangent. So the tangent is going to be, of 32, is going to be the opposite, 10.3, over the adjacent. And like we talked about before, it's perfectly legal to switch these two. So I can say that the adjacent is equal to 10.3 divided by the tangent of 32. Punch that into a calculator. 10.3 divided by 32 tangent equals 16.5, 16 or so. So the adjacent comes out to be 16.5 centimeters, and that is what we said earlier as well. So there's an example of how to do the problem either way, depending on what you're given. Give the problems that I gave you a shot. In the next video, we're going to look at what if they give you a couple sides but don't give you any angles, how we use something called inverse trig functions, inverse tangent, inverse sine, inverse cosine, to find angles. But that's coming up in the next video.